Ever scroll through like Amazon reviews, and you're just trying to figure out if something's worth buying?
Oh, yeah.
Or you see one of those like Twitter storms where it
Hmm.
seems like everybody's either loving or hating a movie or, whatever it is.
Yeah, definitely.
Imagine if you could teach a computer to understand all that,
Right.
to decode all of that human emotion that's hidden in text.
Yeah.
That's NLP.
Exactly.
That's natural language processing, and that's what we're diving into today.
I think what's so interesting about this is how NLP bridges that gap, between
Yeah,
messy human language
totally.
and the precise world of computers.
Yeah.
Like almost building a Rosetta Stone to allow these machines to not just read our words, but to
Yeah.
really grasp the subtle nuances that make communication so complex.
Absolutely. And you've given us some excerpts from this book, Natural Language Processing Recipes.
Right.
And I'm kind of sensing that you're looking for the more practical side of things,
For sure.
less theory, more, hands-on.
Totally. This book is all about the how-to,
Okay.
less about the theory. So it's perfect for someone that wants to really get their hands dirty
I love it.
and actually start building stuff.
Okay, so let's crack this open.
Yeah.
The book starts by talking about this NLP pipeline.
Yeah.
And it's essentially these, essential steps for transforming raw text into something that a computer can understand and then start to analyze.
Right.
It's almost like a recipe in itself, right?
Yeah, that's a great way to put it, a recipe.
Yeah.
So the first ingredient is the data itself.
Okay.
Whether we're talking social media posts, news articles, or even dense academic papers.
Yeah.
It all starts with gathering that raw text.
I'm sensing the next step is probably a little bit of spring cleaning.
Exactly.
Because,
Yeah.
raw text
Oh, it's messy.
can be so messy.
Typos, slang,
Yeah.
all sorts of inconsistencies.
It's the Wild West out there.
Yeah. So pre-processing is all about tidying up this linguistic chaos. So we're talking removing punctuation, correcting those spelling errors,
Right.
standardizing the text.
So we're giving the computer this clean slate to work with.
Exactly. Think of it like prepping the ingredients before you start cooking.
I love that. Okay, so we've got our ingredients prepped,
Yeah.
but the words themselves aren't enough.
Right.
How do we take those words and turn them into something a machine can actually process?
Yeah.
Something mathematical.
That's where the magic of feature engineering comes in.
Ooh.
So this is really the art of transforming words into numerical representations
Okay.
that algorithms can understand.
Gotcha.
So one popular technique is TF-IDF, and this helps identify the keywords that are truly unique
Okay.
and important to a particular document.
So it's not just how often a word appears,
Exactly.
but it's also how unique it is in a specific context.
Exactly.
I can see how that would be super important for like a search engine.
Totally.
It's trying to sift through millions of web pages.
Right, and that's exactly where it's used everywhere. From filtering spam to
Ah.
personalizing your recommendations.
Mm.
It's all about, prioritizing the relevant information
All right.
and cutting through the noise.
Now, the book also mentions this concept of word embeddings.
Yeah.
And this is where things start to feel a little bit like mind reading to me.
Right.
How do we go from simple word counts to actually capturing the
Yeah.
meaning behind words?
Word embeddings are fascinating.
Yeah.
So imagine representing each word as a point in a vast multidimensional space.
Okay.
So words with similar meanings end up clustered together in this space,
Gotcha.
reflecting their semantic relationships.
So instead of just seeing apple as, a random string of letters, the
Right.
computer can actually start to understand.
That's connected to
There's other words like fruit or pie or even, technology, depending on the context.
Exactly. And the book dives into popular algorithms like Word2Vec and fast text
Okay.
that analyze massive amounts of text to learn these intricate relationships between words. So it's like teaching a computer to understand the subtle flavors of language.
So this is all incredibly cool.
Yeah.
But I'm starting to wonder how this translates into like real world stuff.
Right.
How does this NLP pipeline with the, data cleaning and this word wizardry,
Yeah.
how does it actually solve problems that people are facing?
That's where we move from the theoretical to the tangible.
Okay.
And we start exploring how these techniques can tackle real-world challenges.
Gotcha.
And natural language processing recipes offer some great examples to illustrate this.
Okay, let's dive into those examples.
Okay.
What are some of the ways that companies are using NLP to make sense of all this text data?
So one of the most widely used applications is sentiment analysis,
Okay.
which, as you hinted at earlier, is all about deciphering the emotional tone behind a piece of text.
Right.
So whether it's customer reviews or social media posts, businesses are leveraging NLP to really understand how people feel about their products or services.
I've always wondered how Amazon seems to just know.
Exactly what I'm looking for,
Yeah.
even if I don't use the exact words that I'm thinking.
Right.
Is that NLP at work?
Absolutely.
How?
Search engines are heavily reliant on NLP
Okay.
to understand your queries,
Yeah.
match them to relevant content, and even rank those results
Okay.
based on factors like authority and relevance.
Wow.
So it's this constant game of refining algorithms
Right.
to better understand the intent behind our searches.
And I imagine it goes beyond just finding information.
Yeah.
What about tasks like organizing and categorizing massive amounts of data?
So think about a news organization that's trying to make sense of thousands of incoming articles every day.
Right.
NLP can be used for document clustering, automatically grouping similar texts together based on their content.
Gotcha.
So it's this powerful tool for information management and discovery.
So we've gone from extracting that raw text to cleaning it, to transforming it into something a computer can understand.
And now we're seeing how these techniques are actually being used to, analyze sentiment, power search engines, and even organize these mountains of information.
Yeah, it's amazing to see these seemingly abstract concepts have such tangible applications.
And we've only just begun to scratch the surface.
Right.
The book also introduces us to this world of deep learning.
Yeah.
And its impact on NLP, which I'm assuming takes things to a whole new level.
It really does.
Deep learning, that sounds interesting.
Yeah.
Is this where things get really futuristic?
This is where NLP starts to resemble something out of science fiction.
Yeah. Okay.
But before we journey into the depths of deep learning, let's take a quick breather and recap what we've learned so far.
I love it. Let's do it.
Okay. So we started by talking about the NLP pipeline, which is like this step-by-step recipe for turning raw text into something that a computer can actually understand.
Right.
We talked about pre-processing, which is like cleaning and prepping our data. Then we moved on to feature engineering, where we discussed techniques like TF-IDF and word embeddings for transforming words into numbers. So that algorithms can actually work with them.
Gotcha.
And then we saw how these techniques are used in the real world, like in sentiment analysis, search engines, and even document clustering.
Okay, so that's like the foundation of NLP.
That's like NLP 101.
Okay.
The basics.
I love it.
Now we're ready to level up
Okay.
and dive into the deep end with deep learning.
Let's do it. All right, so deep learning,
Yeah.
we've laid the groundwork with the NLP pipeline.
Right.
But I'm ready to kind of explore how deep learning is like pushing those boundaries even further.
Yeah.
Of what's possible with language.
It really is.
It sounds like we're moving beyond, simple rules and algorithms.
Yeah.
And we're entering this realm of, artificial intelligence.
Yeah, that's a great way to put it.
Yeah.
Deep learning is all about enabling machines to learn from vast amounts of data.
Okay.
Mimicking the way that our own brains process information.
Right.
So instead of us explicitly programming rules, we're allowing these algorithms to discover patterns and relationships on their own.
So it's like giving the machine a set of building blocks and saying, like, go build something amazing.
Exactly.
But how does that apply to language specifically?
So think about the complexities of human language.
Yeah.
Sarcasm, humor, metaphors.
Right.
These are things that traditional algorithms really struggle with.
Right.
Deep learning, with its ability to process information in a more nuanced way, opens up all these new possibilities for understanding those subtle aspects of communication.
The book mentions recurrent neural networks.
Yeah, RNNs.
RNNs.
Yeah.
Are these like the building blocks that you were talking about?
Yeah, you can think of them that way.
Yeah.
What makes them so special is that they're designed to handle sequential data.
Oh.
Like the words in a sentence.
Right.
So imagine reading a book.
Yeah.
You don't just process each word in isolation.
Right.
You understand it based on the words that came before it.
Yeah, you need the context.
Exactly. RNNs have that same ability. to retain information from previous inputs,
Okay.
allowing them to understand language as this continuous flow.
So it's not just understanding the individual words, but it's also understanding the relationship between them.
Exactly.
And how they, build upon each other.
Yeah, the dependencies between them.
I can see how that would be super important for something like machine translation.
Totally.
Or text summarization.
For sure.
Where you need to understand the sequence.
Yeah, it's all about the sequence.
To get the full meaning.
Exactly.
So RNNs are great at short-term memory.
Yeah.
Capturing the flow of a sentence. But then there's also these long short-term memory networks.
Yes.
LST, yeah. Which I guess take it a step further.
They do.
Okay.
So if RNNs are good at short-term memory,
yeah,
capturing that flow of a sentence, LSTMs can retain information over much longer sequences, allowing them to grasp connections between words that are even far apart.
So LSTMs are like the marathon runners of the deep learning world.
I love that analogy.
Yeah.
They can maintain their focus over these long stretches of text.
What kind of problems does that unlock?
So one fascinating application is sentiment analysis.
Okay.
But on a much deeper level.
Okay.
So imagine analyzing an entire movie review, not just individual sentences, to understand the overall emotional arc.
Wow.
LSTMs can actually track those subtle shifts in sentiment throughout the text, providing a much richer understanding of the reviewer's feelings.
Now, I'm also curious about the creative potential here.
Yeah.
The book mentions using deep learning for things like predicting the next word in a sentence.
Right.
Could this be used to help writers?
Yeah. Maybe even compose music or poetry.
That's a really intriguing thought.
Yeah.
And we're already seeing glimpses of this.
Really?
So researchers are using deep learning to generate text.
Wow.
That mimics different writing styles, to compose music in the style of Bach or Beethoven.
Wow.
And even create art that resembles the works of famous painters.
So we're on the verge of this creative renaissance.
It feels that way.
Yeah.
Fueled by AI.
Powered by AI.
Yeah.
That's incredible. Are there any potential downsides to all this?
That's an important point.
Yeah.
While the potential is immense, we do need to use it responsibly.
Of course.
So we need to be mindful of potential biases in the data that's used to train these models.
Right.
And ensure that the algorithms we create reflect the diversity and inclusivity of human language.
Yeah, because if it's only trained on a very specific subset of data, it might miss all the nuances.
And perpetuate those biases, which would be bad. Kinds of language and communication.
Yeah.
So it seems like with great power comes great responsibility, right?
Always a recurring theme.
Yeah, shifting gears a bit, I'm curious about the practical implications here for deep learning. Does this mean that all that stuff we talked about earlier, the pre-processing, the feature engineering, is it obsolete now?
That's a question a lot of people have.
Yeah.
And the answer is not quite.
Okay.
It's more of an evolution than a revolution.
Okay.
Deep learning can automate some of those aspects, but it doesn't eliminate the need for them completely.
Yeah. So it's not like we can just take, raw data, feed it into a deep learning model, and then magic happens.
Well, sometimes magic does happen.
Okay.
But in general, some level of data preparation is still really important.
So it's less about, giving the machine this very specific instruction manual.
Right.
And it's more about giving it the tools and letting it figure out the best way to use them.
Exactly. It's a shift in focus.
Okay.
But that doesn't mean pre-processing becomes irrelevant.
Right.
Cleaning the data.
Yeah.
Handling inconsistencies, ensuring quality. All of this still significantly impacts the performance of the model.
So deep learning kind of elevates the importance of good data hygiene.
Yeah, you could put it that way.
Yeah.
It's not necessarily about replacing manual feature engineering.
Right.
But more about complementing it.
Okay.
With automatic feature learning.
Gotcha. So we're still guiding the process. It's just in a different way.
Exactly. And the book gives some interesting examples of how these techniques are being applied to specific NLP tasks.
Okay.
So remember those question answering systems we talked about?
Yeah, like a computer that can actually answer your questions in natural language.
It still blows my mind.
Yeah. How's deep learning making that possible?
So imagine training a model on a massive data set.
Okay.
Of text and code, allowing it to learn those complex relationships between questions and answers.
Okay.
And with enough data, These models can develop an understanding
Wow.
of how to extract relevant information
Okay.
and provide accurate responses, even for complex or nuanced questions.
So it's not just about finding keywords anymore. It's
Right.
like actual comprehension.
It is. It's really impressive.
That opens up so many possibilities.
I know.
For like smarter search engines or,
Yeah.
virtual assistants that can actually hold conversations with you.
Absolutely. And that's just one example.
Wow.
Deep learning is also powering advances in machine translation, text summarization, even generating creative content.
It's amazing to think that, what started as a way to teach computers to understand our language
Right.
has now evolved into this field that's really pushing the boundaries of AI.
It really has.
Yeah.
And the book you've chosen,
Yeah.
Natural Language Processing Recipes, provides a great foundation
Yeah.
for exploring this world.
It does.
It gives you the tools and the knowledge to not just understand these concepts, but to actually start building your own NLP applications.
This has been a really fascinating journey.
Yeah, it has.
From the fundamentals of that NLP pipeline to, the mind-blowing potential of deep learning.
It is mind-blowing.
We've covered a lot.
We have.
But I feel like this is just the beginning.
It is just the beginning.
Of, our exploration of this field.
Totally.
It's incredible. And for you, our listener,
Yes.
the journey continues.
It does.
With the knowledge you've gained from this deep dive and the practical guidance from this book, you're well equipped
You are.
to delve deeper into this world of NLP.
That's right.
Who knows? Maybe you'll be the one to create that next groundbreaking application.
Maybe so.
So keep exploring, keep learning, and keep diving deep into this fascinating world of natural language processing.
Absolutely.
Until next time, happy coding.